Okay, on 13, it is 16x squared is greater than 100. And just like these, we're looking for the x-intercepts. Just like we've been doing pretty much this whole 6 weeks. We've been looking for the x-intercepts. Okay, and I'm going to try to find them in the calculator first because I think that's the easiest way a lot of times. Okay, so when we find them in the calculator, the first thing that we always do is move everything to one side, right? You can also always use the quadratic formula if you want to, if you feel comfortable with that. That works on all of these. Okay, so I'm going to move everything to one side. So I'm going to subtract 100 from both sides because we're going to use the zeros, the x-intercepts, to solve our equation. So we're basically wondering, where is this graph above 0, greater than 0? So will this be an and or an or problem? Or, right? It's an or problem. Okay, it's going to be similar to number 11. Okay, and the first thing that I would do is always try to find the x-intercepts using y equals in your calculator, right? Because if you can, then that's going to be a fast way, right? So I'm going to go in here, 16x squared minus 100. And then in y2, what do I need to put in there? 0, right? To find my zeros. Okay, then I'm going to do second trace 5. Enter, enter, enter. And if I get an okay number like 2.5, I'm cool with that. Okay, if it's ugly decimal, we need to do quadratic formula. So since we got 2.5, what do you think this one is? That looks like negative 2.5 to me. I'm going to check it, but it looks like this is a symmetrical parabola, right? Right, negative 2.5 it is. Okay, so we know that it's already going to be similar to this one, okay, to number 11. So I'm just going to draw a little graph. I'm just going to do negative 2.5, 2.5. Because again, I think it's easier to understand if we draw the little graph. Right, we want to know where it's above 0, right, greater than 0. That's here and here. So this was our solution for this one. What's our solution going to be for this one? X what? Where is it above 0 when x is what? When x is less than negative 2.5, right? Or x is greater than what? Positive 2.5. Good. Okay, you're just using the x-intercepts. Those are the two things that determine what numbers go here, okay, for or problems. And since it was just both greater than and not with no underline, then there you go. X is less than negative 2.5. The graph will be above 0, and if x is greater than positive 2.5, it'll be above 0. All right, let's do the last one. Okay, what do you think it's going to be, and or or? All right, you're probably right. Okay, not always, but probably are right. All right, it's less than or equal to, so that does make it an and. Okay, and problem. For and, just like we did here, when we want to find the x-intercepts first, okay, because that's where the line, that's where it crosses and either goes below or above. So we need to move everything to the same side. So I'm going to add 15x and, subtract 15x and add 34. Subtract 15x. So I get x squared minus 15x plus 34 is less than or equal to 0. Sorry, that should be a subtraction right there. And let's put it into y equals like we did and check the x-intercepts. Okay, x squared minus 15x plus 34. We're going to see it's a really big parabola. It goes off the screen. So, okay. But if I do enter, gives me ugly decimal, right? 2.78, blah, blah, blah. Okay, so I'm going to make a little note that that's what I got so that we can check it in a little bit. Okay, 2.783. Okay, I'm just making myself a little note there so that whenever we check it, we'll see if we get the right answer. So when it's an ugly decimal, we got to use quadratic formula. Okay, that's the best way to solve it. So we're going to label our A, B, and C. Okay, A, B, C. A is 1, B is negative 15, C is 34. And I'm going to plug it in. Okay, so negative B, we've been doing this for a while. So